Okay, hey, I just want you guys to know what isn't going anywhere anytime soon. Knowing where metals, non-metals, and metalloids are. Not going anywhere anytime soon. Knowing valence electrons. Not going anywhere soon. Knowing how to do electron dot notation. Not going anywhere soon.
Anything going anywhere soon?
No. Just put it in your wagon and drag it behind you.
Hey!
I'm assuming you guys got your homework. If you didn't, shame on you.
Yes, I did.
You did.
Chapter
Good job, guys.
18. Moira, you with us? First from Moira. First from Moira. There's a slide up there. Time to put in notes. Are you guys craving a
Periodic table cake.
what?
Periodic table cake. That would
That
be
was
the electrons.
What is a
Someone
stable?
put that here. And also radioactive. They're reactive.
We don't want radioactive.
But not like radioactive, but like just a symbol.
So this is where we start doing bonding. So you think valence electrons are going anywhere soon?
No.
Yeah, no.
No, because valence electrons are a result of bonding.
I got a question.
What?
Are you ever gonna show us how you put cheap metals into
Gold.
I just forget.
I even wrote you a note.
You did,
And I need
threw
that
it
sheet
away.
of paper. You do.
Oh.
I needed that back.
Oh.
I needed it back.
You did?
Yeah.
Why would you write something on a piece of paper if
You
you
didn't have
it?
anything else.
Are you
Is
an
it
idiot?
over? What?
You need to
Oh
give
my
it?
gosh, I'm gonna be another.
that means you just give stuff to people and take it back.
Yeah. Alright, principles of bonding. First section here.
Wait.
We're gonna talk about how things react.
Oh my gosh.
We're gonna talk about element relationships.
Oh man, you're getting into a relationship.
Yeah, this is gonna be deep, guys. We're gonna talk about courtship and regular, unbiblical dating. And
Engagement.
we're gonna talk about how you make a stable relationship last. Okay. Okay. Here's the simplest way to make a stable relationship last. Don't get in them.
Hey,
Alright.
amen to that.
Ours needs this one.
Amen.
Don't write this in. Here are some questions we're going to address this chapter. Do all elements bond with all elements?
No.
We just like mingle with each other, just hang out, and just have a good old fancy time.
Dude,
Yes.
What
socialization.
if it's a long distance relationship with lithium and argon? Would that work?
Long distance relationships can work, but that one won't. Okay?
It's not good.
Turns out they're both boys.
Oh!
Homework.
That is not bad.
Wait, how do you know there's a boy and there's a girl?
Pretty sure this joke's whatever.
Because they don't go together. If they don't go together, then there's no.
Yeah.
Oh.
Just doesn't work. Okay? If not, which elements bond to which? We're going to figure out why argon won't bond with krypton. Potassium. The reason why argon won't bond with potassium is because argon's already stable and has no need to bond.
Amen.
Oh.
Amen.
Oh, it's
It
a
is-
single guy.
Argon has a very good relationship with Christ. It doesn't need another.
Oh. That's
Amen.
Whoa! It's just me, myself, and I.
Okay? Why do some elements bond and others do not? Why does krypton not bond? And the answer isn't.
Stable.
The answer isn't that it's got a good relationship with Jesus. It just isn't. But I thought that was fun. Wasn't that fun?
Yeah, safer for
Do
Jesus.
the elements that bond all bond the same way? Now, we're going to answer all these questions in this chapter.
No, I didn't get
Can we write this down?
Wait, you're not supposed
I
to
weren't,
write
you
it.
weren't supposed to write that.
Oh, dang it.
Kramer, can we write this down?
You can write this down. You want this. You want this. This is why things bond.
Bless you.
You can have your ghetto, no cards back.
Hey. What you doing for?
Have
Ouch. If you don't ever go to the store, why not?
That's okay. I buy all my clothes at consignment shops. Except
Goodwill.
I don't ever
Woo!
buy. I don't ever buy
I
clothes.
hate the Goodwill so much.
You do?
Go to
You hate
Amazon.
Goodwill?
Why?
You like getting
Parents
bad
dragged me there.
well?
Mike,
Oh.
Okay.
Yes.
I have a question.
Yes.
So, I know it's not a problem.
Okay. Is it quick?
Yeah.
Okay.
For the basketball game tonight, do we have to go or is it just our parents?
Good question.
Your parents are supposed to go. Whether you go or not, I don't know.
Because if I don't have to go, I'm probably gonna want to go to the open game.
Well, I'm assuming if there's open gym, you should go to open gym.
But
You don't have to go to the-
There is open. I didn't know
Ask Grant.
there.
Ask any other basketball player.
Oh, the guy that plays drums?
no.
That's Brady.
He doesn't even play basketball.
And Grant doesn't even play the shoe. Is it snowbound?
Yeah, just find someone wearing Jordans and ask them.
Or fine.
Let's find someone wearing Jordans.
Alright, here we go. So, why do things bond? Here's why things bond. They want to be stable. Now, what you might not intuitively understand is stable means low energy. Unstable means high energy. Imagine walking into a room with a bunch of little children. That's a very, very unstable environment because those children have very high energies.
They're
Would be
working for a
terrifying.
lifetime.
They probably take their toy swords and stab you with them.
Oh.
Okay, now imagine all your grandparents in a room.
They stable, so they got all 8.
They're just, half of them are asleep, the other half are playing pinochle.
What?
Yeah.
That's actually
It's a card game.
That's actually a pretty good game.
It's a fun game.
not with my family.
Not with your family, it's not a fun game, okay?
No, it's not.
so-
So, them all.
So the point here is that is a really low energy environment and it's pretty stable. Pretty close to death, but stable. That wasn't funny. No, that was a little.
That was a little.
I crossed the line on that one.
Yeah, you did.
Rewind. Imagine you're in a room.
Can't rewind on the camera.
You're right. I shouldn't have said that. Shame on you, Mr. Kramer. Okay, so we're going to talk about this, but what ends up happening is things happen with the electrons and the nucleuses of the bonding elements that causes an attractive force because we know that positive things are attracted to negative things. Okay, yes.
What's pinnacle?
It's a card game.
With your knuckles, you
What is pickle? Is pickle like tennis?
Pickles, yeah, some sort of sport. I don't know exactly.
There's squash and pickle. Why do we name sports after
I think squash is like close to what
Isn't it because
racquetball
of
is.
carrot?
Okay, hey, we gotta go.
My bad.
We gotta go.
Sorry.
You need to know this though, guys. Okay? Things bond to become stable, and stable means low energy. Okay? If you have lower energy, you're more stable. And so the reason why a lot of these elements aren't found by themselves is because they're more stable bonding with things. The reason why typically the noble gases don't need to bond is because they already are stable, because stable from an energy standpoint usually is the result of having a full octet. We'll talk about that today. What is an octet? The octet rule. Okay, that is the rule that says that elements are typically most stable when they have 8 valence electrons. Well, what is the only group that has 8 valence electrons by itself? The noble gases are group 18, the far right there. So, okay, all the other guys need to do something to get 8, and they will bond to do so. Hey, octet rule, there it is.
1, 2, 3, 4, 5, 8, easy.
Oh, add an extra E to be okay.
it says usually most stable here because there are some things that are stable without A, and there are quite a few exceptions when you take much higher level chemistry classes with me that we talk about how some things can be stable with more than 8. Okay, but that is quite a few years away for you guys. What is that?
What? It's an electrostatic shock, or a shock, it's a shock.
Electrostatic shock that creates a shock when you rub it on the ground. Alright?
Yeah, we should have that.
Alright, let's talk about this. Did I talk about how these guys here tend to lose electrons? Did I ever talk about that? I thought I drew a picture on the board showing you that if you had potassium and it loses its one valence electron, it loses that energy level and acts like stable argon.
Yeah, you said that.
Didn't I show you that?
Yeah, you did.
Okay, I thought I did. Okay, so here's what happens here. Is you've got these guys are metals. Here are the nonmetals. The nonmetals are really close to achieving an octet by gaining electrons. The metals are close to achieving an octet by losing electrons. So we're going to talk about how there's a variety of ways to attain an octet. Okay? However, there are a few that couldn't attain an octet if they wanted to. Hydrogen can be stable with having how many? You know? Gaining one more and having 2. Hydrogen acts like the noble gas, helium here, when it only has 2. Do you remember how many fill the first energy level? 2. Okay? Now, lithium, beryllium, and boron are closer to being stable by losing their electrons and acting like helium than they are in gaining electrons and acting like neon. For example, how many valence electrons does boron have? 3. Is it easier to lose 3 or gain 5? Probably easier to lose 3, huh? And again, it wants to be stable, it wants to do as little as it can to be stable. Beryllium has how many valence electrons? 2. Is it easier to lose 2 or gain 6? Lose 2. Lithium has 1. Lose 1. Easier to lose 1 than gain 7. Okay? So that's why it says the first 5 elements, there are exceptions for those guys. Okay? Here are ways that they can achieve an octet. You can gain, you can lose, and you can also share. Okay, I'm not going to go too crazy into these yet because we'll talk about these 3 ways to have an octet when we talk about the 3 types of bonding, which we're about to talk about at the end of today. Okay, but just at this point, know that these are the 3 ways that you can do it. We'll talk about how and why as we progress through. Okay. Some other things we need to talk about before we get. Yes, a big vocab word here. Oh yeah, I need to print out your vocab sheet.
Is it electronic or?
Electronegativity.
Oh,
Yeah, you have to know how to say it. Electronegativity. That's better.
Well, let's see.
Octet rule. That was what?
Are you talking about C as in, which C? There's a lot of C's.
Electronegativity.
Yeah, I think I took one out, probably. So make this C if you want. Yes, but I haven't printed it off yet. I forgot. So I'll try to get that to you as soon as I can. If you're really dying to like work ahead over the weekend, you can come to me after school and I can print it out for you.
I'm not.
I figured you weren't, but
I have too much going on. My dad's leaving to Colorado.
you're moving
Yeah.
to Colorado?
No.
His dad's going to
Oh,
go.
yeah, you said.
My dad's going to Colorado for
And while he's gone, you guys are moving?
Yep.
Wow, he got lucky draw there. He doesn't have to do anything.
He's gonna move all his stuff here. We got done
Where's your new house located?
that. 5 minutes down
Oh. Where was your old house located?
the road. 15 minutes.
Well, that could be.
North, south, east, west, northwest, east, south, southwest, east, north,
You just say east south.
southeast. Could be east, west. That's right in the middle. Depends on what you said is the origin. It's not fun. I'm jealous. It's on here.
You're funny here.
Yeah. I'm a tryhard. What are you doing, Rose? You feel what? Stepped on your face? Oh boy. Alright, okay, at least there's a reason, because if like half your face goes numb, you're probably having a stroke. So, we don't want that.
What?
Like, is it heart attack or stroke? I can't remember. One of them makes like half your body go limp.
I
Like,
think that's a stroke, because that's in your
stroke.
brain.
That's
Yeah.
a stroke.
Yeah, makes sense.
That's a stroke, that happened to my
Okay.
dad.
So, here's really the definition of electronegativity. We're probably not going to finish today. Okay? Electronegativity is how strongly an atom attracts electrons when it's bonding. So what this simply means is there are some things up here that attract electrons more strongly than other things. The things that tend to attract electrons really well are the things that probably take electrons. The things that don't attract electrons really well are probably the guys that lose the electrons. And we'll talk about that process as we progress here. But what electronegativity is really how well some particular element attracts or holds onto electrons when it's bonding. Okay? Electronegativity determines whether or not an object's going to lose the electrons when it bonds, whether it'll gain the electrons when it bonds, or whether it will share. It depends on the two things that are bonding. For example, if you have two things that both want electrons, they will share. If you have two things that one has a low electronegativity, doesn't want electrons, and one with a high electronegativity does want electrons, one will give, one will take. The one that doesn't want will give, the one that wants will take. And it all has to do with how much they want electrons, or their electronegativity values. Yes?
So, like, you're talking about losing and gaining an electron, right? But the atom have to have the same number of electrons.
If it's neutral.
So
Okay? So, ionically bonded things, one gives, one takes, and the reason why they are attracted to each other is because one's positively charged and one's negatively charged, and that's what holds them in the bond. But the overall charge of the whole thing is still neutral, because if you take the positive and the negative and combine them, you're still neutral. Does that make sense? So this is, I would probably, okay, this is good, but this is really what you need to know. You need to know that the metals tend to have low electronegativity values. The non-metals tend to have high electronegativity values. This is why metals have a low attraction for electrons, because they don't have a strong desire for them, which is what a low electronegativity means. Popular today.
Congratulations.
Is your phone still being PG?
Yeah.
You get an upgraded phone.
Okay. So halogens. What group is the halogens?
17.
17. All of those guys are nonmetals, right?
Correct. Oh.
So it says that halogens really want electrons. Does that agree with the fact that they have high electronegativity values? The things that have high electronegativity values want electrons. The things that have low electronegativity values don't. So these nonmetals here want electrons, and it should make sense. Aren't they fairly close to becoming stable by gaining electrons? For example, fluorine has 7 valence electrons, only needs 1 to be stable. But lithium only has 1 and would have to gain 7 to be stable, so it's far likely just going to do what? Lose 1 because of its such low electronegativity value, or lack, or no desire for those electrons. Yes?
So low electronegativity don't want electrons.
Yep. Things that have low electronegativity don't typically want electrons. They don't have a strong pull for electrons, and they're easily removing. You can easily remove electrons from them. Nonmetals tend to have high electronegativity values, and they're more difficult to remove, and they actually want. As we progress, this will make a little bit more sense. Why would noble gases have no electronegativity values? They're already stable. They don't need anything. Okay, you already kind of got this, so I'm going to write this. You could, right, yeah. Sure, write that alkali metals part, but that's.
Have you ever seen that, like, actually snap them
Never seen them snap a mouse, but you saw it snap a mouse before?
Like in person? Yeah.
How did, when?
I went to Michigan, I went to a farm. They had this mousetrap set up so they could show us how it works. So we had it, and the mouse was in the cage, and the mousetrap, the mouse went over to the phone. It was crazy. So it went up. It just like, the mouse like rotating while it was snapping.
Sounds beautiful.
Thanks for that.
I'm hungry now.
I got that.
I don't like mine. I mean, mine's so cute.
Alright,
Well, mouse traps are animals.
okay, alright, so. So maybe you should put that. You should put. So I do want you to put this in. I do want you to put metals gain electrons. No, sorry, that's wrong. Metals lose electrons. And I also want you to put that non-metals will either gain them or they will share them. And I will explain what causes them to gain in certain situations and to lose or share, in other situations.
So metals lose electrons.
Now, does this make sense why metals lose and how that relates to the fact that they have low electronegativity values?
Yeah.
Okay? The reason why they have low electronegativity values is why they lose electrons. They don't want them. They don't need them. It's much easier for them to lose them to become stable than to gain them to become stable. Okay? Non-metals tend to gain because they're really close to being stable. They only need a few more to become stable. So they have a strong desire for them. Now, why they would share them has to do with what if two non-metals bond together? What if you have two things that both want? Think they're gonna compromise?
No.
Share.
They'll share.
Yes.
Yep.
What's that? Wait.
So here are the
You had some.
If you just understand that here your metals have your low electronegativity values and your non-metals have your high electronegativity values, there's technically a trend here. As you go to the right, you get more electronegative. As you go to the left, you get less, and as you go down, you get less. But you can understand that just based on non-metal and metal location. Because you can see here, as I go up into the right, I become more electronegative. As I go down to the left, I become less electronegative. So you might want to put this in. Francium is your least electronegative element, and fluorine is your most electronegative element. Why do you see helium, neon, and argon have no electronegativity values? Why do they don't have a single electronegativity value?
Stable.
They're already stable. Now, you're probably wondering, well, why does krypton and xenon have electronegativity value? That's for a much higher level. I have to tell you all the sublevels and how energy levels fill, and then we have to talk about that for a while. Yeah. Okay? Francium has the lowest electronegativity value. Fluorine has the highest electronegativity value. All right, there are three types of bonds. First type, covalent. Actually, let's stop here.
Really? Yay.
Let's stop.
We'll erase that C that I wrote down.
Let's stop here. We will finish this on Monday. So no homework over the weekend. How about that?
Amen.
Wait, we don't have to do that homework?
Nope.
You gave us